Hello everyone, today is December 4th and let's open a new LeetCode problem from our coding advent calendar. I hope you had a chance to take a look at it already and solved it. If you are not, don't worry, I will help you with the solution in just a couple of seconds. So let's the problem solving begin. Here is our today's problem. Minimum average difference. You are giving a zero-indexed integer array nums of length n. The average difference of index I is the absolute difference between the average of the first I plus 1 elements of nums and the average of the last n minus I minus 1 elements. Both averages should be rounded down to the nearest integer. Return the index of the minimum average difference. If there are multiple such indices, return the smallest one. Okay, note, the absolute difference of two numbers is the absolute value of their difference. The average of n elements is the sum of n elements divided by integer division by n divided by n. The average of 0 elements is considered to be 0. Okay, here is an example. 2, 5, 3, 9, 5, 3. And equation is the following. For the first element, 2 divided by 1 minus 5, 3, 9, 5, 3 divided by 5. Okay, here is the equation. And result is 3. Then we add new element 5 to the left part and take it from the right part and we get 2. Then we add 3 to the left part, take it from the right part and we get 2. Then we have 0, 1 and 4. And 0 is the smallest result of the equation, and we need to return this index. It is 3, and for this one we should return 0. Constraints. So the length of array is pretty big and values inside this array is also pretty big. What does it mean? If we are going to sum these elements of such a big array, we are going to overflow our integers, so we need to take care of this. Another interesting thing is this 0. The last element of this array should have 0 elements on top and 0 as a divider. We cannot divide by 0, so we should take care of this case, this corner case. Okay, how are we going to implement this? So first, I'm going to take some of these elements, this array. Why do I need this? I'm going to instantly have a value of this right part, this sum. How I am going to do this? I'm going to have total minus current index from here. Okay, so let's start. So our total is considered to be long total, and I need to have some of these nums. How I'm going to calculate this sum? I can't just apply some link expression to it because it will return integer, and integer will be overflow. Result will be more than max integer. So I'm going to do like this. Okay, so I create a variable total. I go through elements which are integer, and I will add this value to total. So I have total. What next? I will define the value I'm going to return as a result. So our index 0, and I'm going to define a variable where I'm going to store the minimum average difference. I will initialize it like this because the next equation will result something smaller than max value of long, so it will be overridden immediately. And I need to go through our array. Okay, here. Okay, one more. I need to have a variable to store a left part of the equation before I divide it to the number of elements. So it will be sum. Here we have our first element, and we will add it to sum. Now we can calculate the left part of our equation. We have our array 0 indexed, so in order to count number of elements, not indices, we need to add 1 here. So we will take our first element here, 2, sum will be 2, and we will divide 2 by 1. And we need to track our right part of equation. It is total minus sum divided by number of elements left from this array minus number of elements taken here. But we need to trace the last index when we have 0 here and 0 here. We cannot divide by 0, so we need to take care of this case. Okay, so we have our left part of the equation and right part of the equation. So let's calculate the diff. Okay. That's it. Okay. Let's try to submit our solution. Okay, it is accepted. So let's try to estimate the time complexity of our solution. What we do here, we go through the all the elements in an array and calculate total, that big of n. And we have a loop here to go through all elements again and calculate our diff and track the minimum one. So it also big of n. So time complexity is big of n. What about the memory? We use only a few variables here. We don't create any lists, collections, or arrays. So from memory perspective, it is constant time, big of 1. And I don't think it is possible to solve this problem better. That's it. Problem solved. I hope you enjoyed today's video. Please don't miss the next problem on LeetCode. I will release a detailed solution for it tomorrow evening. See you tomorrow.